Hello everybody, welcome back to the next set of AP150 mini lectures. This first set of mini lectures is going to deal with some basic chemistry. Our textbook is a really good textbook, it's very clear, but it doesn't have a chapter on chemistry. And I think it's useful to have a basic background and some chemistry ideas because there are a few that we'll make reference to on a semi-regular basis in the class. Likewise, the textbook just starts jumping in and talking about certain chemicals as if you are familiar with what they are. And for those reasons, we're going to do a little bit of chemistry. Now, in this first mini lecture, we're going to talk about elements and atoms. Okay? So let's start off by looking at this image right here. This is a diagram of the levels of biological organization, and we looked at this in our last set of lectures. And I just want to point out where we are in this level of organization. Today we're going to be discussing the chemical level of organization. And there's two different structures that exist at the chemical level of organization. There are atoms, which are the first structure, and then atoms combine together to make molecules, which are the second structure present at the chemical level of organization. So let's start talking about this chemical level of organization. Right? The human body, like everything that exists in the world, is made up of these fundamental materials known as elements. And what you can see on the screen now is what's known as the periodic table of elements. It lists all the elements that we've discovered. And depending on what chemist you ask, there's between 90 or 98 naturally occurring elements. And some of these elements you're familiar with or have at least heard of before. Things like gold and silver and iron are elements, and so are things like potassium and calcium and carbon and nitrogen and oxygen. Okay? Now, of all of these 98 or so naturally occurring elements, 99.5% of the human body is made of just 4 of them: hydrogen, carbon, nitrogen, and oxygen. The other 0.5% of your body is made of kind of a collection of other elements that exist at very small quantities. Right? So if we take a look at this image right here, we can see the nitrogen, hydrogen, carbon, and oxygen that makes up 99.5% of your body, and you can see just this tiny slice right here, right, is made up of what we call trace elements, things like calcium and phosphorus and potassium and sulfur and so on. Some of them exist in really small quantities, even though they're necessary for you to live. Right? So even though iodine exists at very small quantities, without it, you would die. Now, these elements can either exist in their pure state in your body, or they can be combined together to make molecules, which we'll talk about in a little bit. Right? But each of these elements has its own unique set of characteristics or properties. And what gives each element its own set of characteristics or properties is the structure of its atom. So let's talk about atoms. Now, there are certain characteristics that are shared by all atoms, no matter what kind of element they are part of. All atoms are made of 3 particles. Now, keep in mind these atoms are infinitesimally small. We cannot see atoms, not even with the most powerful microscope. Right? But these atoms are made of 3 smaller particles, and each one of these particles has an electrical quality or characteristic to it. For example, these little red particles here, those are protons, and protons have a positive charge. So sometimes we abbreviate that P positive. Right? Clustered together with the protons, we have particles known as neutrons, which are electrically neutral. Right? And you can see that protons and neutrons are clustered together. We'll come back to that in a minute. And the third particle are known as electrons. They're these little dark circles, right? And the electrons have a negative charge, right? And the electrons zip and move around the center of the atom, which is known as the nucleus. So the protons and the neutrons clustered in the center of the atom, that forms the nucleus. And what holds the atom together is the attraction between the negative electrons and the positive protons. What makes the atom of different elements different is the number of protons and to a lesser extent the number of electrons that it has. Right? For example, hydrogen has 1 proton and 1 electron, whereas nitrogen has 5 protons and 5 electrons. And so the number of protons and electrons and the different number of protons and electrons between hydrogen and nitrogen is why hydrogen behaves one way and nitrogen behaves another. Oxygen has 6 electrons and 6 protons, so it behaves in another entirely different way. Now, atoms can bond together to make molecules. So for example, if you had an atom of nitrogen and an atom of chlorine, they could bond together to make a molecule known as sodium chloride, right, which is table salt. Right? Or if you had a hydrogen and an oxygen and another hydrogen, you could combine them together to make a molecule of water, right? H2O, right? You have 2 hydrogens, and there's 2 of them, and then oxygen. Or you could have a molecule of nitrogen binding together to another molecule of nitrogen, right? Which makes N2. That's the type of nitrogen that's in the air. Or oxygen binding to oxygen to make O2. That's the kind of oxygen we breathe. Or you could have a molecule of carbon bonding together to 2 molecules of oxygen to make carbon dioxide. Right? Or you could get way more complex and you could have 6 carbons, right, bonding together to 12 hydrogens, bonding together to 6 more oxygens to make glucose, right, which is a sugar. And so that's the idea behind atoms and molecules.